All right. I think we'll get started, and hopefully more people will join as we do the intro. Thanks for joining. My name is Didier, and I'm the technical lead for the HP developer community. Today, this is our September meetup, and we are welcoming Alex from the Iterative to discuss the DVC, machine learning data version control. And before Alex goes on, I will just spend a few minutes talking about some of the things we do with the HP developer community. And first of all, we run those meetups. We started this program in January 2022, so it's pretty recent, but we've managed to get speakers every month, and in most cases, external speakers, such as Alex. We've run this, as I said, monthly, and we record this and make them available quickly after the meetup, like 1 week, through our meetup page, which Denis, my colleague, kindly pasted into the chat. We have a session planned in October already from Pepper Data, and they will present on boosting Spark AI workload. And this is also presented by Pepper Data, so that will be interesting. We do another type of sessions that we started last year called the Munch and Learn, and these are a little more like thought leadership, trends, vendor and product agnostic type of talks. We have the page for registering to those and watching the replay for those on our website, and Denis has pasted the links. We don't have yet, I cannot really confirm a session for October. We are working on something on sustainability with our friends from the HP labs, but this is not yet confirmed, so I cannot really give you a title. The date I know is 19th of October, if we can make it, but I'll let you know through the website. Other things that we do, and which is relevant to this audience, I think, is those workshops on demand. I don't know if you're familiar with this, but I would suggest you give it a try. What these are is Jupyter Notebooks-based workshops that you can access over the internet 24/7, free of charge. And we have a catalog there with about 28 workshops as of today. I think 19 of them are open source topics, such as Docker 101, Kubernetes 101, Ansible, many other subjects are covered there. And you can register, do the workshop, and if you do, be kind enough to provide feedback, so we get some interesting feedback on what else we should build, and if you like it or if you didn't like it. Because this is a community and we need community members to grow that community and to make it live, we need a little bit of work from you all. First of all, we'd like you to join and invite other folks to join our talks. And we have also a monthly newsletter, which you might find interesting. We can sign people up, and the link should be in the chat again here. Feel free to register. It's a monthly thing, and there is a link to unregister just in case in every single newsletter that we send. So we also have a dedicated Slack channel. I know HPE has an internal Slack, but this is an external dedicated Slack channel for HP Dev that we pay for. You can join that. There are a lot of questions on our different platform which are relevant for developers. And they are asking questions, we are trying to answer, or we are escalating to engineering teams and other folks if we cannot. But that's another good place to join and tell your customer about. We have a huge Twitter handle with almost 200,000 followers. If you're a Twitter person, you can use that. If you'd like to engage more with us, we'd like to remind you that you can contribute to blogs. We have a pretty easy system to work with based on GitHub and on Markdown. So if you're a developer or it's pretty straightforward to contribute to blog. We're always on the lookout for interesting subjects. If you're a subject matter expert, don't hesitate to share your knowledge with us it's a matter of maybe 1 week to get a blog up on the website. We totally own that website, and we make several updates per day. So we're talking about a relatively small effort. So don't be shy and talk to us for blogs. Same thing, if you're a subject matter expert on a particular topic, we can schedule a meetup with you if it's something you would like to do. So don't hesitate to ask. Same for workshops on demand. Right now we have a catalog of 28 workshops, but we are always interested in finding out other options and things that we could do. And if you want to build something with us, speak up. That's it for me. Thanks for listening. You can get all those links Denis has already pasted in the chat from that QR code. You can share that slides with customers when you talk to them. Many still don't know that we have a developer community, and I think we need to make this better known. So with that, we'd like to turn over to Alex for the real content of that session. Thank you.
Okay, hello everyone. So today I'll be presenting kind of machine learning experimentation with DVC and VS Code, and I'll teach you why reproducibility matters when it comes to machine learning experimentation, and how we can collaborate more efficiently as data scientists, machine learning engineers, and software engineers. So I guess I see two kind of profiles that will benefit the most from today's session. Either you are a data science and machine learning practitioner who wants to be a bit more introduce better and software engineering practices into your workflow, or on the other hand, if you're a software engineer developer who just started playing with machine learning and want to see kind of what tools are out there. So to set the stage, this is an example machine learning problem that we'll be dealing with today. So imagine if you work at some bank and you've got a data set about your like this bank's customers, and whether they've recently left the bank as a customer or not. So based on some descriptions and features about each individual customer, you're trying to predict whether they're likely to churn or not. And that obviously, like from a business perspective, it's much cheaper to retain existing customers than to attract new ones. So as data scientists, or just someone who got their hands on this data and just started playing around with it, you might be kind of at this stage, which is fairly common, where you have a Jupyter notebook. In this Jupyter notebook, you might have some code that does like data loading, maybe some data exploration as well, and then cleaning your data, feature engineering. Finally, you train your model and do model evaluation. So you compute your metrics, maybe look at some evaluation plots to assess your model's performance. If you're at this stage, you might start asking yourself a few questions. Some questions might be like, what exactly was used to produce a particular model? Like in terms of code, data, and configurations that you set. Can you easily compare many machine learning experiments, right? Every time we train a new model, we change something and would like to compare them, like what led to improved performance, what didn't really matter. So we'd like to be able to answer those questions. And finally, will you be able to reproduce your results later? And we are asking ourselves these questions because we want to achieve certain goals. And within the framework of this presentation, I picked kind of three goals that I consider to be important. Goal number one is obviously we want to achieve best possible performance. Here I mean like model performance. And achieving best performance often means running many, many different machine learning experiments. And for the rest of this talk, when I say an experiment, what I really mean is a very particular combination of code, data, and configurations that went into producing a particular model. Our second goal is ensuring reproducibility. So why is it important? Why is reproducibility important? Well, first of all, if we are trying to improve model performance, like we cannot do that like in one day, right? Typically, we kind of go back and return to our model and we iterate on it. But if we cannot reproduce past results, we cannot really improve upon them, right? So you can't improve what you can't reproduce. Secondly, transparency and team collaboration. So it's important to know if you are part of the team that works on the same machine learning project, it's important to know what your team members did in order to achieve certain performance. Did they use a different data cleaning techniques? Did they use a different model architecture, different set of hyperparameters? So you'd like to have that transparency and not without having to kind of go through a lengthy research and investigation process in order to find that out. And also within certain industries, auditability can be extremely important, if not critical. Answering questions like what exactly went into the models that prescribe treatments to patients or determine creditworthiness of bank customers, those can be under like regulated by laws in certain countries. And our final goal is having minimal setup and dependency on third-party services, because many machine learning experiment tracking solutions right now, they require you to instrument your code with their framework specific code. So that introduces a certain level of vendor lock-in, so that if you realize later on that you're not satisfied with this tool that you're using right now, it's not an easy task to make a switch, right? So we'd like to avoid that. Secondly, there's maintenance and cost, because some solutions require you to maintain your own infrastructure, such as machine learning tracking server, which requires you to like maintain a virtual machine, a database, and so on and so forth, or you pay them and they'll take care of it for you. But the kind of the relevant to this idea of like paying them and sending your data to their own infrastructure, that might be potentially a security concern, right? Because even though you're not sending your actual data that you're training your model on, but you might be sending some like metadata, which can still be problematic in the context of certain like business units. And most ML tracking solutions, at least the ones that I'm familiar with, have at least two of these problems. So whether it's MLflow, weights and biases, Comet ML. So these three, you might have heard at least of one of them. And the fact is, it's different to achieve all three goals at the same time. So again, we'd like to iterate quickly to generate many experiments. We'd like to automatically track all changes to our code configs and our training data. And would like to avoid or minimize dependency on third-party services to store data, metrics, and parameters. And here's a couple of examples. So I already mentioned MLflow. So here we have, what you're seeing is 5 different machine learning experiments. So there's 5 columns in here. Every column represents a different experiment. And at the bottom, you can see different metrics that we're able to achieve for each of these experiments. Problem is, if you like look at this table closely, you'll notice that every single value in this table across 5 different experiments is identical. Yet we have vastly different performance metrics at the bottom. And unfortunately, it's just too easy to achieve that with many of machine learning frameworks, because you can change lots of things that are not being logged unless you explicitly want to log that change, which is not easy to do. So you end up in a situation where you have several identically looking experiments with different metrics. So obviously it's not easy to reproduce a particular one. And it's the same situation with other tools like weights and biases. If you notice in this table, again, 5 different experiments because they have different performance metrics, yet all the parameters that are used for these experiments are the same. So what I'm suggesting in this talk is, if you're in doubt which kind of stack to use, go with open source. And there are a few reasons why you might prefer that. Is typically popular open source projects, they have big community, and with that comes a lot of support. So you can create like a ticket in GitHub or GitLab, whatever that project lives, and then either core maintainers or people from the community will be able to help you out. Also, open source projects, because they're free, they require either kind of zero or very low cost to set up. And you have visibility into their kind of public roadmap and discussions, like what features can you expect in the future? Like how do they prioritize existing bugs and so on. And what I'm suggesting today is for machine learning experiment tracking is using a combination of 3 open source tools. One is Git, another one is VS Code, and DVC. So DVC will use it to set up DVC pipelines, and this will allow us to generate lots of machine learning experiments. And also DVC will allow us to version large artifacts such as datasets or models in some remote storage, those that cannot be versioned by Git. We'll obviously use Git to version code and configs. That kind of goes without saying. And we'll use VS Code as a convenient UI for experiment management. And with this combination of 3 open source tools, there's no need to maintain or pay for additional services. So why DVC and what's DVC? So DVC is a command line tool. As I mentioned, like DVC itself stands for data version control. So many people know it by its data versioning capabilities, so that you can integrate DVC and Git to version large artifacts that don't fit within Git. It also provides you a framework to create machine learning pipelines, essentially chain multiple operations together. And it also gives you functionality to manage your machine learning experiments. And these two come with kind of integrated data versioning capabilities. And you'll see in the live demo shortly what exactly I mean by that. And so, yeah, it's open source, integrates with Git. And finally, it's language agnostic, it's platform agnostic, so works on Windows, Linux, and Mac. And it's also storage agnostic, so it supports pretty much any remote storage you can think of. So AWS S3, Azure Blob Storage, Google Cloud Storage, SFTP, SSH, what have you. So what are DVC pipelines? So DVC pipelines are essentially a way for you to chain very common operations when it comes to machine learning modeling. So a very typical pipeline could look like where you start with some data loading, data cleaning, and featurization. Then you split your data into train and test. During the training stage, you train your model on the training data, and then finally evaluate your model on the test subset of the data to produce plots and metrics. So with DVC pipelines, you can create a pipeline either from individual modules. For example, it could be like Python modules, or it can be just one notebook that does everything. So for example, on the left-hand side, you can see this is a typical pipeline definition. You define it in a YAML file. On the left-hand side, you can see that I have 3 different stages. Each of them executes a very specific Python file. There is a stage that does data preprocessing. There's a stage that does model training, and finally evaluation. Or on the left-hand side, there's a pipeline that essentially consists of one stage that runs a notebook that does everything. And there are pros and cons of using either running your notebook or refactoring your notebook into individual self-contained modules. And we'll go over that in a second. But once you have your DVC pipeline defined, you can run different machine learning experiments through command line by simply running DVC experiment run and passing a new value for a particular hyperparameter that you want to change. For example, in this screenshot, I'm changing number of estimators in my random forest model to 120. And DVC reruns my pipeline with this new value of my hyperparameter. And I can run a few of those experiments. And when I do that within VS Code, I'll see this user interface where there's a table that contains all my experiments. It will also display all the different parameters that I used, as well as different performance metrics that I achieved with my model. So now that I've kind of hopefully set the stage and provided enough context for you, let's actually see how that works in real life. So I've got an example demo repository. So as I mentioned earlier, our example use case today is predicting bank customer churn. So here's a data set. It's a public data set that I got from Kaggle. It has 10,000 items in it. Every item describes a customer, their credit score, country where they come from, gender, age, their estimated salary, and a couple of other features. And the column that we're trying to predict is the last one, called exited. And it's a binary column, so 0, 1, indicating whether a customer left that bank or not. And once we define our pipeline, so here I have a pipeline with 3 stages: data splitting, so it splits my data into train and test. Training, it's obviously trains my model. And finally, evaluation, which computes my performance metrics and evaluation plots. So this is my pipeline. And if you're using VS Code, and you can go to a marketplace and find a DVC extension. So if you search for DVC, you'll find this DVC extension here. Once you install it, you'll see it on this sidebar. And we can see a table with experiments and plots. So let's start with table of experiments. So right now, I don't, what you see is the metrics that I was able to achieve with this pipeline on my main branch, and then 2 previous commits on the same branch. So they're the same because I didn't really change any parameters of my model. As you can see here, it's all the same set of hyperparameters in the 2 previous commits. So now what I can do is run an experiment. So let's right click on main and start searching for a hyperparameter of my model. For example, max depth of the decision trees. I can change it from the default value of 15 to, let's say, 20. Press enter, and the extension will run this experiment for me. So it did that pretty quickly, and we can see that there's a new entry in this table, right? So the metric value changed just slightly. We can make it deliberately make this max depth parameter very low, let's put 3, and we'll see that the metric should decrease significantly because this is a very suboptimal value for this parameter. Yeah, so we can see that our F1 score went from 58% to 23%. So that's not a good experiment. And we can generate kind of as many experiments as we want, and they'll just be added to this table. So we can sort by different metric values. And if there are experiments that we want to get rid of, we can simply remove them from this table, and that's it. So we can also fairly easily tune our hyperparameters and run what's called a grid search. So what that is you can pick some hyperparameters that you want to optimize for, For example, here I picked number of estimators and max depth. And I can provide just like Python code. So this is a range for this particular parameter. I'm saying that I want to explore all values within the range between 50 and 200 with a step of, let's say, 30. And for max depth, I want to explore values between 10 and 25 with a step of 5. By the way, if you know Python, so the last number within this range is not included. So it will be 10, 15, and 20. Here it's going to be like 50, 80, and so on, not included, 200. So I can simply run this command first. Let's copy that. Look at my experiment table. And I'm going to run this DVC experiment run command. And it does something. So what did it do? So it put those experiments, so basically that grid of hyperparameters, into my experiment queue. It didn't run them. That's why you see the metric values are empty. But it did generate all the like permutations for those two hyperparameters that I selected. And now if I want to execute them, I can simply start the queue, and DVC will generate many, basically run each experiment one after another and show the metrics in this table. And this will take like a minute or two to run. While that's running, I can also show you that we can, in the plot section, we can select different experiments and compare it, for example, with what's on our main branch, right? So here I decided to display area under receiver operating curve. So this is my receiver operating curve, and I can compare the two experiments. I can also compare confusion matrices. So this is a common visualization for binary classification problems. And this is a normalized confusion matrix. So basically we expect for a perfect model to have 1 on the diagonal and 0 on the off diagonal values. Obviously I don't have a perfect model, but one of them is slightly better than the other. Okay, so that might take a while for these experiments to run. Let me actually terminate it. But if we wait for the table to populate, we'll be able to kind of see several experiments along with their metrics. And imagine we found an experiment that has the highest metric that we care about. At this point, we might want to share our results with our teammates, right? So here we've got a few options. We can right-click on this experiment, and we can, for example, apply it to workspace. So what does it do if I click on it? What happens is the extension resets my current workspace to the state of that experiment. So it resets my hyperparameters, it resets my metrics, as well as all the like plots and so on and so forth. At this point, I can just go ahead and commit my experiment, provide some git commit comment. For example, say run grid search, and just commit all these files. So that's one option. The other option, for example, we can create a new branch or share our experiment as a branch. Let's actually do that. I'm gonna name it as HP Meetup. And what's happening right now is DVC creates a separate Git branch out of this experiment. And let me open up this repository, which lives on GitHub. Let's check out our branches. And there you go. So this is the branch that I just created. If we switch over to it, everything is here. So all my changes to hyperparameters, to my code, or even if I change the data set, all of it would be recorded here. And then if I did change the data set and for example, my resulting artifacts, such as my model, have changed, I can simply push it to some remote location by running a DVC push command, similarly to git push. But DVC push doesn't push your large artifacts to a Git repository. It pushes it to some remote storage that you can configure. In my case, it's an AWS S3 bucket. So now that I've run DVC push, everything in that, all the artifacts are versioned within this S3 bucket, so that I can always go back to the state of my repository at a particular commit. So that's that's it for the live demo. Let me just do the quick summary of what we've just covered. So we talked about common requirements for machine learning experimentation, which is the need to generate a large number of experiments. The need to version everything. And by everything, we mean code, configs, and data. And also the requirement to have minimal setup and external dependencies. And what we've covered is with a combination of open source and free tools such as Git, VS Code, and DVC pipelines, we can address all these requirements by using Git for versioning code and configs, using DVC for generating machine learning experiments and versioning large artifacts such as datasets and models. And finally, using VS Code for visualizing and managing machine learning experiments. So that's it for the presentation today. So I'm open to any questions that you have.
Let's see, we had Jervis answering questions. I don't know if he was talking about one that was not answered. Is there an option to parallelize the grid search by running the different experiment on multiple nodes?
No, not at the moment, but it's something that our team is looking into, and how to parallelize experiments that can be run independently of one another. But you can also, like, obviously, if you run it on a remote machine, which is something that we have another open source tool that allows you to do that, you can speed up that experimentation for sure. Yeah, and I see that Jervis linked to that tool. So it's CML, stands for continuous machine learning. And you can set up your CI/CD pipelines to essentially, your workflow would be that you would first commit a change to a code or data set or parameters to Git. And then your CI/CD workflow can provision a more powerful machine that you have locally, rerun your pipeline with a set of new changes, and then report the resulting metrics back to your repository. I should also mention, since we have a little bit of time left, that with DVC extension for VS Code, it's not only, like, I only showed you like one set of features for managing experiments, but it also, once you install it, it adds kind of another section to this source control panel in VS Code that allows you to manage your data that is versioned with DVC, right? So you can pull and push your data from the remote storage, and you can also easily see kind of what is currently in your is being tracked by DVC. So I can see that this is my original data set, for example. These are train and test subsets that were produced by one of the pipeline stages. And this is one of the models that I'm tracking. So you kind of have this full integration, just like with Git.
Thanks.
Yep.
I brought up the poll for people to tell us if they think it was useful. But if you have more questions, we have time for more questions, so don't be shy. All right, so if we don't have any more questions, I guess, well, there is one. Will the data, if some column selected, store again fully?
Right. So if I understood the question correctly, if the data changes, what will happen to kind of the way that DVC versions it? So the short answer is if this, like in this particular example, if my CSV file changes, let's say if I add, just copy paste a couple of lines here, just copy and paste them. So now imagine like my data changed. I'm simply rerunning my pipeline. First of all, DVC will, I need to first tell DVC that it's to start tracking my data. This will generate a new metadata file, and this new version of the data will go into the remote storage. And then when I rerun my pipeline, it will notice that the data has changed, rerun the kind of the pipeline, and generate new metrics. So if, I guess the short answer to your question, yet, if the one file changes, then DVC will version the entire file. But if you have a directory with multiple files and you keep, let's say over time, you keep adding more files to it, DVC will do the duplication on a file level for more kind of efficient use of your remote storage space.
Yes, the replay will be made available on our page and on the meetup page where you're registered. And there's another question from Miguel. Can you show how you would track possible model drift due to data change?
So DVC by itself does not do kind of monitoring for data drift. But what you could do in order to like help with that, if you could use a model that you trained on, like let's say in the past, maybe a month ago, and now you've got a new subset of your data, you can simply rerun the model against this new subset, calculate your performance metrics, and then compare them to what you had in the past. And if you see a significant deviation between the metrics that you had in the past against the metrics that you calculate on the new data, then this would be a good indication of the data drift. But we don't provide like any details like about the distribution changes or any statistical tests. This is not the point of DVC.
Thank you, Alex. Any additional burning question for Alex? Thanks for checking and showing on the live demo that things can be done. It's really interactive. That's great.
Yeah, absolutely. And I guess I can share in the chat the link to the repository itself if people want to clone it and play around. Yeah.
Thank you. Thank you, Alex. I think that was a great session, very interactive, and we had some very interesting questions. Thanks, people, for answering the poll. We will close the call and talk to you next month. Thank you again, Alex and Jarvis.
Thanks for having me. Bye.
Thank you.